Today we're going to talk about some interesting concepts about infinity, about the universe as such, about the three-dimensional matrices. You know, so many people are absolutely daunted by the 22 frets on an average electric guitar like this with 6 strings. I know many guitarists that play really well, they actually don't know the notes names they're playing in many instances, and they certainly don't know the intervals. Now, the root to all great modern music is knowing intervals and the relationships between notes. I really sincerely believe that. Now, this is going to get a bit hairy for some of you, because we look at the stars and we cannot figure out where the universe begins and where it ends. And I know we're obsessed. If you're watching this channel, you're obsessed with music like myself. What is music? Well, it's sound waves. Now, we know 4,500 years ago, the Greek mathematician Pythagoras, 4,500 years ago, by using a mathematical branch of mathematics called calculus, he computed and came to a conclusion there are 12 distinct pitches in an octave, which is represented on the guitar on the top, thick E string at the 12th fret. So the guitar's fretboard in one octave has 12 pitches. Now let's assume for this, initially we have a one-string guitar. It's represented in some of our diagram there. There's my string, and that string represents infinity, because if I could make that string long enough, that same pattern of scale notes, which we give the name C to B and then back to C, in both directions it will get lower in pitch that way and higher in pitch that way, and it would continue if we could just stretch it out into infinity. The same 12 notes will reoccur on that string. That I'm calling my x-axis on an XY graph I'm going to share with you soon. Now, because of the infinity nature, in other words, the notes keep recurring, I'm representing them in a circle, in a one-dimensional world. You follow? You'll move from C to B and back to C, and you can do it in both directions. The pitch will either get lower in that direction on the fretboard, if we had an infinite guitar neck, and it will get higher in pitch to a point where our human ears wouldn't pick up the frequencies on either end. So that's the circle. We'll come back to the circle later. Now back to the two-dimensional graph. I want to put this theory into 2 dimensions now by adding, so we talked about the x-axis, the horizontal axis, which represents the 12 semitones in an octave, which continue infinitely as explained by those arrows. And now I want to talk about the y-axis. Now in my theory here, we're using the y-axis to measure the specific intervals from a given position on the fretboard. I'm picking the note of C. I want to know on my y-axis here, it sounds almost a bit like that movie, Space Odyssey 2000. Anyway, that's my y-axis. Well, I'm going to tell you, if I pick the C note and gave it the number 1, or my tonic, the note below it is the 4th, because guitar in standard tuning, let's make that assumption here for this lecture, an F is the 4th note in the C major scale. The note below that on the D string is a flat 7th interval to the C. It's a B flat. C, F is my 4th interval. That's my B flat, it's a flat 7th. Now I've got an E flat, which is my minor 3rd interval. I've got a G, which is my major 5th or perfect 5th interval. And I've got my C again, 1 or 8 or 15, whatever you like. Add 7 each time. So now we've got our horizontal octave as we move up and down the infinite string. And now we're dealing with just 6 strings in this example, not infinite for now. What is the distance from the tonic to the other notes on the y-axis? Okay, just bear that in mind. I'm then going to represent, once again, the C string if I assume I have an infinite amount of C strings, there's my C notes. We move in each circle D, E, F, G, A, B, C, and on we go. And I'm showing you different circles because those are C strings in different octaves. These tiny little dots in between here, now I want you to visualize a donut shape here, much like the Milky Way, or these patterns that occur in our universe. Now, I'm no scientist, no mathematician, but I want you to use your imagination here. Try and see this as a 3D diagram, like that label on the 7th single of Black Sabbath, Paranoid. You know, that's vortex or whatever they call it. The donut shape is referred to, a three-dimensional donut shape, by the way. If you bought yourself a Krispy Kreme donut, that is referred to as a torus in mathematics, I'm told, which is depicts an infinite. It's, think of terms of the universe, you know, star formations. You know, Pythagoras believed that the planets are attracted by magnetic fields and create vibrations as they fly around each other. You know, he reckons they give off sounds that our human ears can't hear because they're outside our scale of hearing for our CPU, our brain. Okay, now, the diagram I'm looking for is this one, where I'm trying to take you into a three-dimensional world now. So I've talked about the two-dimensional world, the XY diagram. I'm going into the three-dimensional world, so you can see your one string with a C note, and there's the next string with a C note in a higher octave, and so we go on in infinity. I will add, much like a slinky. If you're going around this thing up higher and higher and higher, your human ear won't hear the sounds. But as I explained to you earlier, these little dots here in the two-dimensional, well, I want you to see it as three-dimensional. In those little dots are representing my y-axis connections. Now, I didn't want to put all the dots which are possible because there's an infinite amount, even in that space, because my y-axis is only examining the relationships from one particular string in 6 positions. In other words, as I explained to you, there's one, a C note, an F is a 4th interval, a B flat is a flat 7th, an E flat is a minor 3rd interval, and G, as I explained, is the perfect 5th interval to the C note. Those are the little dots in that diagram. My point is, I'm trying to show you diagrammatically what a beast of an instrument you're dealing with here. Now, you're only dealing with 132 depressible notes on a 22 fret 6-string guitar. So what's the problem with you not understanding what the notes are and the relationships? So I've taken you outside into hopefully a bigger dimension, and maybe even wondering where the 4th dimension is. For example, but I need to go back one more step. I only examined the relative nature of the intervals from a C in a vertical, on the vertical axis. But if I move the axis as it can move infinitely in both directions, I'm going to start getting these things. And thus I said to you, those little dots there are infinite, because there are so many different interval you can use. For example, I'm going to go like this now on a diagonal basis. C to an E is a major 3rd interval. C to that note there is an A flat. It's a flat 6 to the, and that one there is a C again. So it's a 1 and an 8, or a 1. And that one there is an E flat, and therefore it's a flat 3rd again. And that one there is a perfect 5th. And if I came down, there's 1, flat 5, 8, flat 5, a 7th, and a 4th, an F to a C. Now, I'm just giving you some idea. But if I moved to a B flat and I did the same thing, the good news is the relationships of those intervals does not change. That's the good news. And that's if the guitar's in standard tuning, then the theories always remain true. And that's going to give you competitive advantage to feed your brain all this information and I'm going to give you much more practical examples how to use intervals in the traditional way, but there's thousands of those videos on YouTube. But I want you to think bigger, because if I give you a bigger weight to pick up, you're going to find the other 380 kilogram powerlifting weights feel like feathers. If I gave you 1,500 weights, if you could pick it up. But I want you to expand your mind into a bigger thing and to say to yourself, it could have been a lot worse. Because on an infinite guitar scale or musical scale, you're really dealing with a small little piece of the universe here. Now, the patterns that occur in nature are often referred to as exponential functions or law of diminishing returns. It's phenomenal how the law of normal distribution occurs in statistics. It's mind-blowing. In fact, most mass manufacturers use statistics, mathematical calculus technique. I have a little bit of training in that, but we won't go there. It is mind-blowing. I have done videos about 3 years ago about the probability of hitting an E note on a guitar's fretboard. What is the probability of hitting an E note? Well, we know there's, I believe there's 5 of them, and there's 132 notes. The probability of depressing an E note is 5 in 132. No, there's probably about 10, because there's 2 octaves. Sorry, I got that wrong. But these are things you need to consider. But the chance of you hitting it randomly is very small, percentage-wise, okay? So forget about just playing at random. It's an infinite topic, and I know I'm waffling, but I'm only hoping by this to change your thinking by taking it into an expansive world of vortexes and matrix, 3-dimensional, maybe 4-dimensional matrices. I want you to think about this. This is deep thinking material. As I said, see that diagram in your mind, but see it as like a slinky that goes on infinitely in both directions. And then the little dots in my other 2-dimensional diagram are these relationships of notes vis-a-vis another note. But because of the guitar's tuning between the B and the G string, we're moving from 4th intervals to a major 3rd. So therefore the interval relationships will change in a guitar in standard tuning. And if you did a drop C tuning, then obviously your relationships or the intervals to each other will change. You've got to acknowledge that. But I just want to give you food for thought. And the main one is, you don't have to worry more than 2 octaves. Well, there aren't only 2. There's two octaves vertically up to the 12th fret, and then there's another 2. You really only have to worry about 4 octaves when you play a guitar. The good news is the first 12 repeat themselves. So you really only need to know 2. For example, C major in 2 octaves. Okay, so you really haven't got too much to worry about. Sorry about that, I'm a bit excited and got it wrong. It's C, D, E, F, G, A, B, C, D, E, F, G, A, B, C. I'm a bit excited, as I say, but you know what I'm talking about. And look, I know I can cop a lot of criticism for this, but I mean good. And I really hope it does help you to expand your thinking. But it's up to you to go start figuring things out. I will give many more, as I said earlier, practical lessons on intervals to keep you focused on where you need to be. Like that's an A major and that's an A minor by lifting one finger, because that's the major 3rd interval, also referred to as the 10th, because if you played A major, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then you understand, you're assigning numbers to the notes. You find yourself counting, not saying C, D, E, F, G. You find yourself saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then you're on the right track. This is powerful stuff, but That's the narrower side of intervals, and that's probably all you need to play your guitar like an expert one day, or all the theory. But really, I hope this out wide dimensional stuff expands your mind to think how you fit in to the universe of music. Thanks. They'll probably come collect me now. Cheers.